Controlled fire is necessary for industrial progress. Without it, civilization as we know it would quickly disappear. But uncontrolled fire is a destructive force that takes many lives and destroys billions in property values each year. A surface fire, such as in a plant, differs from an underground mine fire. In a well-run plant, firefighters are trained for an emergency. Ordinarily, a plentiful supply of water is available, and other first aid firefighting materials are provided at convenient locations. This does not prevail in all underground mines. As a rule, less equipment is available. Persons trained in firefighting are the exception rather than the rule, and firefighting may not be as prompt. Underground mine fires are less accessible. Methods for fighting and escape are more difficult to plan and rehearse. Also, there are the dangers of toxic fumes and explosive gas that threaten men who may be trapped in by a fire. In an operating coal mine, a fire presents the greatest potential disaster hazard, involving death and destruction. To prevent fires, the origin should be known. To maintain an efficient firefighting organization, the members should know the nature of fire. There are three primary elements of fire, which can be illustrated by the fire triangle. To produce combustion, first there must be fuel or combustible material, such as coal or wood. Second, oxygen or air must be present to support combustion. Oxygen comprises about 1/5 of normal air. Third, a source of heat is necessary to start combustion. Common heat sources are electric arc, open flame, overheated machines or cables, and spontaneous ignition of accumulated waste materials such as oil-soaked rags. There are three general classes of fires: A, B, and C. Class A fires are those originating from solid combustible materials, such as coal, wood, rubber, textiles, and paper. Class B fires are those started with flammable liquids, such as oil, grease, paint, and lacquer. Class C fires originate with live electric equipment, such as cables, motors, generators, and switch panels. Returning to the fire triangle, if any element represented by a leg is removed, fire cannot exist. For example, if fuel is eliminated, a fire is extinguished by starving. If air or oxygen is shut off, combustion is stopped by smothering. If heat is removed, a fire will go out. An old saying goes, an ounce of prevention is worth a pound of cure. Fire prevention, whether on the surface or underground, should be the first line of defense. Once a fire breaks out, an efficient firefighting organization is the second line of defense. This calls for training and the availability of suitable materials and equipment to combat fires. Combustible materials are plentiful in coal mines. Common among these are wooden timber, oil and grease, flammable belting, canvas, hose, and coal. Investigations of the causes of coal mine fires, including preventive recommendations, have contributed to minimizing their occurrence. Important means to prevent fires are good ventilation, proper application and maintenance of good rock dusting to neutralize combustible dust that's deposited on mine surfaces, the availability of water to allay dust that's generated in coal mining, proper maintenance of electrical machines and equipment, and good housekeeping. Roof bolting has minimized trolley wire dislodgement from hangars. thus preventing arcing and falls of roof on haulage roads. Fire-resistant belting in conveyor belt transportation, together with fire-resistant trailing cable insulation, are also valuable in preventing fires. Modern mine mechanization has introduced certain fire hazards. To operate large machines, such as continuous miners, large quantities of hydraulic oil or fluid are required. But this hazard can be minimized by using fire-resistant hydraulic fluid. There is no substitute for knowledge and training to develop firefighting skills. Once a fire breaks out, it's too late to train. Therefore, the importance of fire prevention cannot be emphasized too strongly. To counteract the danger points, particularly overheating of electrical parts and conductors, fire protection must be relied on. This involves extinguishing or controlling fires by trained personnel who use proper types of firefighting equipment. Most fires can be extinguished or controlled if they're discovered and attacked early enough. The point is that training and skill must be backed up by proper types of first aid firefighting equipment. Now let's join a class of firefighting trainees and see demonstrations of 5 types of fire extinguishers that are approved by the National Fire Protection Association and are recommended by the Bureau of Mines for underground fires. This is a water pressure type. The essential constituents of this extinguisher are water and a high-pressure cartridge containing an inert gas such as carbon dioxide or nitrogen. When the cartridge is punctured by bumping, water under pressure is released. Here are 2 other water-type extinguishers, one with a pressure grip handle and the other with a push-button release mounted on the carrying handle. To activate the grip handle type, a release pin must first be removed before pressure can be applied to the lever. The button type merely requires slight pressure on a button release. To obtain maximum efficiency in the use of any extinguisher, the manufacturer's operating instructions must be followed. Sometimes chemicals are added to increase the wetting efficiency of water. The soda acid type, which contains bicarbonate of soda and sulfuric acid, is a common type of extinguisher used around coal mines. This extinguisher is designed to be carried to the fire, and to be activated, it must be inverted or turned upside down. While the discharge contains products of chemical reaction, the extinguishing agent is principally water. Because this type is activated by turning the extinguisher upside down, it must be stored and transported in an upright position. By wetting as much of the surface of the fire as possible, the main flame will be extinguished. Then any small isolated flame should be attacked. These types of extinguishers are used on Class A fires, consisting of solid combustible material such as coal, wood, rubber, textiles, and paper. For Class B fires, 3 types of extinguishers are suitable: dry chemical, foam, and carbon dioxide. The dry chemical type consists of a pressurized container of dry chemical connected by piping to a nozzle. The chemical is discharged when the container is pressurized by an inert gas, released either automatically or manually. The foam type of extinguisher contains foam salt and acid salt solutions. When released, they mix, creating a tremendous flow of foam, consisting of bubbles filled with carbon dioxide gas. This type of extinguisher spreads a blanket of foam on the surface of a fire and smothers it. This is particularly effective on highly flammable liquid or oil fires. Another type of Class B fire is one that results from leaking or spilled flammable liquid. A carbon dioxide, dry chemical, or foam extinguisher is effective on such fires. For Class C fires, which are of electrical origin, an extinguisher must be used that has a quenching, cooling effect, but must not be a conductor of electricity. Dry chemical or carbon dioxide types are recommended. The carbon dioxide extinguisher consists of highly compressed carbon dioxide contained in a steel cylinder. In using the extinguisher, the gas is released by a wheel or a squeeze grip lever valve. Both the dry chemical and carbon dioxide extinguishers are excellent for Class C fires. The flared horn or nozzle is pointed toward the base of the fire and the trigger is pulled. The proper method is to start at the edge of the flame nearest the operator and work toward the center of the fire until it's out. The dry chemical type contains a fire-quenching powder and an expellant stored in a cylinder or cartridge. When released, the expellant forces the powder through a high-pressure hose and nozzle onto the fire. A vaporizing liquid such as carbon tetrachloride should not be used on fires in confined places because deadly toxic gas is generated by the heat. This is a life and health hazard, not only to persons using the extinguisher, but to anyone downwind from it. Caution must be observed in storing or using some extinguishers in freezing temperatures. Sometimes it's necessary to add antifreeze to the contents of extinguishers. You've seen some first aid firefighting equipment. Other extinguishers, available in much larger capacities, such as truck-mounted tanks, are similar in action to the hand types. Halfway measures or half-hearted compliance with accepted firefighting practices will result in a false sense of security when a fire breaks out. Let's join several tours of inspection of underground fire protection facilities in different coal mines, illustrating the various types of firefighting equipment. All haulage locomotives should be equipped with fire extinguishers, suitable for fires of electrical origin, and also for oil and combustible material fires. Many mines have water pipelines installed on haulage roads. These lead to working areas and furnish water to allay coal dust. Sometimes such pipelines are used for firefighting purposes. Outlets should be provided at intervals not exceeding 500 feet, and the water flow pressure maintained at least 50 pounds per square inch at each nozzle. Enough rubber hose should be provided to reach at least 500 feet from each outlet. If not connected to a regular water supply system, at least a 5,000-gallon water storage should be provided by tank or reservoir. Sometimes mine pump discharge lines can provide water for firefighting if such lines have outlets for fire hose connections not more than 500 feet apart. Also, where compressed air lines are available, they may be used for firefighting, provided they can be converted quickly to water lines with suitable outlets and acceptable nozzle flow pressure and capacity. Additional firefighting equipment is advisable where water lines are available because of possible disruption of the water supply. At some mines, water tank cars are provided. Each mobile tank unit should have not less than 1,000 gallons capacity, but 2,000 gallons is preferable, together with a high-pressure pump and at least 300 feet of fire hose to deliver 50 gallons of water per minute at a nozzle pressure of 50 pounds per square inch for each unit. Before the introduction of fire-resistant conveyor belts, fires from belt friction were common. An automatic sprinkling system installed at belt loading points is desirable. Should excessive heat be generated by fire, a deluge of water would be released to the surrounding area to extinguish the fire before it reaches serious or dangerous proportions. Such a system is particularly valuable at unmanned belt loading points and at other unattended installations. Fire extinguishers for Class C fires and supplies of rock dust will augment firefighting facilities at such points. Records of some coal mine fires reveal that many were discovered by one or two workmen. If workmen are unable to extinguish the fire readily, they should warn persons that might be endangered and notify the proper authorities. To do this, a good communication system is necessary to all sections of a mine, preferably an intercom system or telephone. Escapeways to the outside, which are accessible from every section of a mine, are one of the best precautionary means to avoid entrapment of workmen by a fire that cannot be readily controlled. Escapeways afford workmen a means of orderly, safe exit in an emergency. Direction signs to escapeways should be erected and maintained in legible condition. Here is the foam plug method of firefighting, in which water is used with a foaming agent to produce a mass of bubbles that's forced by air pressure to a remote fire zone. This mass of bubbles or foam is generated by spraying water on a net. The net frame is carefully installed to prevent air leakage. Leakage at this point would result in forming a ragged, slow-moving plug with insufficient water carried to the fire area. The basic requirements for foam plug technique are relatively simple. A high-pressure foam plug unit consists of a foam generator, proportioning pump, foaming agents, a portable fan, and of course an adequate available supply of water. Air that passes through the continuously wetted net produces a mass of bubbles that fills the mine passageway. The lightweight plug, carried forward by air pressure, moves around corners and over obstacles. It should be mentioned that in actual operation, the foam fills the entire mine opening. But to permit observation of the foam action, it was necessary to restrict the flow to the seat of the fire. primary purpose of the foam is to transport water to a distant fire. The heat of the fire will flash the water in the foam to steam, resulting in an air-steam mixture with an oxygen content well below the percentage necessary to support active burning of most flammable materials. The foam plug method has certain limitations, such as the distance foam can be transported successfully, the requirement of electric power near the fire area, and the need for an adequate supply of water. Care should be taken in using a foam plug where energized trolley or other live electrical conductors are exposed. Foam may also affect the ventilation pattern. This must be considered carefully when using it in a gassy coal mine. Mechanization in face areas increases the danger of fires and therefore intensifies the problem of providing adequate fire prevention methods as well as adequate firefighting facilities. Various theories are advanced as to the best type of firefighting equipment for combating coal mine fires. Under many circumstances, water is the best means of extinguishing such fires and should be available for that purpose. Pipelines must be large enough in diameter to ensure adequate discharge of water at the farthest outlet. A pipeline should be large enough to permit a nozzle discharge of not less than 50 gallons of water a minute at a flow pressure of 50 pounds per square inch. To assure better firefighting facilities, water fire lines can be interconnected with water spray lines by installing a bypass valve at each working section. The safety concept for fighting fires at the face should not differ materially from other protective measures in coal mines. The problem cannot be solved by water alone. Extinguishing agents other than water may be required. Rock dust and handheld chemical extinguishers are first aid protection against fires in a face area. This equipment can be backed up with large mobile dry chemical extinguishers, foamite, or loaded stream types. Such supplemental equipment can be stored in the last crosscut of an entry or some other suitable place. Here is a portable, high-expansion foam generating unit capable of forcing a foam plug into the face area of a dead end. This small unit can be installed and operated in a short time. It consists of a mobile-mounted axial flow fan that controls the quality of foam production. A honeycomb air strainer with a net in the exhaust end produces the foam. The quality of foam can be controlled by the operator after observing it at the exhaust end of the fan. When the fan is started, the tubing unrolls in the direction of the fire and can be controlled by opening and closing the inlet regulator to maneuver the tubing over and around obstructions. If the tubing is too long, it'll be burned off when it reaches the flame. As it approaches the fire zone, the heat will draw the foam toward the fire. This unit is not intended to replace the primary means of firefighting, but as a supplement. 2 trained men can put it into use in a short time. It operates at ordinary pipeline water pressure. The unit is capable of delivering 600 cubic feet of foam per minute through as much as 250 feet of 24-inch tubing. The foam envelops the fire and eventually extinguishes it by its quenching and smothering action. Sometimes coal mine fires cause loss of life, loss of production, and considerable property damage. Fires may get out of control because of inadequate firefighting facilities or lack of firefighting personnel trained to use equipment promptly and effectively. It's important to train men, but it's also important to provide them with good equipment. All equipment should be inspected and tested at least once every 3 months, often enough to disclose and eliminate any defect in the firefighting equipment. All hand-type and truck or wheel-mounted fire extinguishers should carry a tag with the inspector's name and date of inspection. Safety training is one of the most effective means of developing safety consciousness. Such training includes fire prevention and firefighting procedures. A competent person should be delegated to visit each production crew at frequent intervals, instruct the employees in the different kinds of fires and how to use the different types of firefighting equipment. Materials and tools for erecting seals and for changing ventilation in an emergency should be stored in suitable strategic locations that are known to all underground workmen. A map showing the locations of firefighting equipment and escapeways indicated distinctly on it must be provided and kept up to date. A copy of the map should be posted at strategic points in a mine and in the mine office on the surface. A self-rescuer should be available for each underground workman and a few extras for visitors. Training in the use and limitation of this device is necessary. Well-equipped mine rescue station under the supervision of an instructor who trains rescue teams and inspects equipment is provided by some companies. The instructor can also be utilized to train personnel to fight mine fires. When a fire cannot be extinguished by direct or indirect methods, the last resort is to seal it. This requires an established procedure, and the following factors must be considered: the chemistry of combustion, balancing of pressure in sealing both intake and return airways, and efficiency of the seals. When sealing a fire area, a good practice is to insert a pipe with a valve in one or more seals, through which atmospheric samples can be withdrawn. This will help in determining when it's safe to reopen a sealed area. The Bureau of Mines developed a fire-resistant, quick-sealing compound called rigid foam that provides an effective method of constructing stoppings and seals. Tests with rigid foam also indicate its potentials for other uses, such as controlling ventilation and mine rescue and recovery operations. It can be used to improve ventilation in everyday mining of coal and other mineral products. Rigid foam can be used as a protective coating for mine roof and ribs to reduce spalling. It also has good heat insulating qualities. In 20 minutes, 2 men can erect a stopping that's as effective and under some conditions better than one constructed of concrete blocks. Few, if any, industrial plants have as unfavorable natural conditions for combating fire as ordinarily prevail in a coal mine. Conditions such as concentration of electric machines and conductors in close quarters, forced ventilation, liberation of explosive gas from the coal bed or associated strata, and the hazard of roof collapse caused by heat of a fire. Such handicaps provide a real challenge to the ingenuity of the industry. First, to prevent if possible. Otherwise, to control or extinguish fire by approved methods and equipment. The Bureau of Mines and other safety-promoting agencies will continue to investigate and study the nature of mine fires and new methods of combating them. However, we know enough about the causes of most fires, how to prevent them, and also how to extinguish them if they should occur. It's up to you to apply this knowledge effectively when an emergency arises.